intro. I am very happy that I am known now as Tim's +1. Yeah, I was also, let's say, we didn't really work together that much. He joined and I left for. Oh, have you met him? Okay, cool. Whoa. All right, let's see. Okay, I have to just stand here, I guess. Or can I take the mic?
Take it off, yeah.
Even better. Cool, because I like to move a bit. All right, thanks so much. I will also be doing a giveaway. I'm going to give away a couple of stickers later after the talk, so come and find me. So it's great to be here. Thanks for inviting me to come over. This is the first time I've been to the States since 1998. So very vividly, I remember 1998, if you want to know how far ago that was. The news of the day was Monica Lewinsky. That was, I remember that very, very vividly. So apart from that, apart from the fact that I live in the Netherlands, other things that might be interesting to know about me, I'm just moving the cursor out of the way. Yeah. As you said before, I'm a developer advocate with Loft Labs. What we do has to do with multi-tenancy on Kubernetes. It is not necessarily what I will speak about today, so if you're interested, just come talk to me or my lovely colleague Rich later. Before, oh, right, so if you want to get in touch with me, you can find me on the Bird app, Twitter, as Lian makes things, or you can send me an email to lian@loft.sh if you really want to get down to business. Before being a developer advocate, I used to be a consultant with Container Solutions, and during that time, I've learned a bit about, I helped customers transform into the cloud, so I definitely learned a bit about kind of weird organizational structures and how our customers were trying to kind of make this journey into cloud native. That also obviously requires a little bit of shift in culture and organization, while at the same time also, of course, doing the technical transformation. So this will all be kind of like, this all flew like into this talk in terms of like where kind of the ideas are coming from. All right, I'm just starting to ramble. I'm still a bit jet lagged, so bear with me with this. All right, so just to jump right in, during the Kubernetes journey, or during the journey that I made, kind of like learning about Kubernetes, one of the things that I realized was that secrets on Kubernetes are not really secret. So yeah, once you have access to someone's cluster or namespace, you can read all the secrets that are in there. And the reason why Kubernetes secrets are not secret is because of the secret resource, just the way that it's defined. So this resource looks like this, and here in this data field, we have two keys, in this case username and password, and the value here is not encrypted, it's base64 encoded. So if I had access to this cluster and I could just like read the secret, I could just copy paste the values in here and put them into like a decoder, and then I would be able to read the actual content of the secret, which is not good. So yeah, this is the data field that we looked at. So now, in the olden days, what we would have done maybe is just to give our devs no access to the infrastructure. So you just couldn't, connect to the server yourself. But nowadays, with Kubernetes and with kind of like the next iteration of CI/CD, one thing that has become quite popular is to do GitOps. And let me just show of hands who's familiar with GitOps. Okay, that's most people. Who has used it in production? Who's using GitOps? Okay, all right. So for those who are not super familiar with it, the way that it works, or the idea is that you will have a definition of your desired state in a Git repository. And it works pretty well with Kubernetes, because in Kubernetes, you just have these YAML files that represent the resources that you want to deploy into your environment. So one of the big advantages of GitOps is that you can deliver all your resources in one place, so your ops repository, and basically just by looking at that repository, you know this is the state that we want it to be in at this given time. I'm not going to say that this is what happened, because that's a whole different problem. Other things that just are really good with using GitOps is that you have the access control built into your Git provider. Usually that would be GitHub, for example, so you don't have to manage all of that yourself. And you have a persistent history of the states of your environment, because your Git log or your Git history will be persistent. Little caveat: you can theoretically change the history of your of any Git repository or Git branch. There are ways to mitigate that. You can do things like lock down changes, restricting branches, and all of these things. But in theory, it's not completely immutable. So you need to look out for that as well. And one of the things that we have to keep in mind, though, is that with Git, if the developers have indirect access to it, either they can write to the repository themselves, or there's some kind of technical user that will write to that configuration repository in their names, then devs might have read access to that repository. Because they have write access, they might be able to read it. And if we put our secrets in the GitOps repository, then we're back at this problem that I can see the secrets and they're not encrypted, so I'm able to read the contents of the secret. So these are the things that we need to consider when we do GitOps and work with secrets at the same time. So I want to take a step back to talk to you about something called desire paths or desire lanes. This is something that you might have seen in real life. It's basically caused by erosion of humans or animals who will take a specific path, like their favorite path to cut through, like a corner or something. And the thing about desire paths is that if you have infrastructure that's just really badly built, like the one on the left, or infrastructure that's just really inconvenient, like the one on the right, you will see that people will take another path. And these are the desire paths. And at the same time, as you can also see, because everyone's taking this other path, it will actually weaken the structure of your entire architecture. Or maybe organization. So if I now make the kind of do the metaphor back to software and software systems, what can happen is because people are taking this other way, using this kind of exploit, that this will make your entire system less safe. So with that in mind, what we need to do when we think about how to make it possible for engineers to work with secrets in whatever platform we're providing to them, we need to think about their desires and what the desire path is that they want to take. So these are some ideas that I had, some things that I put together for a case that I think is pretty normal, pretty common, but this might be different for your particular organization, and that's totally fine. So these are in numbered orders because I think that there are priorities to those objectives. So we would first say, when I consume those secrets, I want them to be the same. I want to consume them in the same way across all the environments. So one example for situations where that is not the case is if you have in your code a point, like an if-else, if I'm currently living on production, then this is the way that I'm going to read my secret. And if I'm living on development, then I'm going to read my secret some other way. So this is an example of something that we do not want to have, because we want our application to be completely oblivious to where it lives and why it lives there. Second, we want to keep the secrets out of the hands of developers as much as we can, specifically on production, of course. So if possible, we want developers to not ever know the content of the secret. We would like the developers to have a good experience working with secrets. Generally, we would like developers to always have good experiences. With secrets, what I've seen is that in some organizations, you have to create, like a ticket maybe to say okay, I need some database credentials. Can you please put them into this environment? And then it takes a week before the secrets are there. And then, by that time, people have already switched tools 3 times. And then finally, something that I think is super cool, again, for some companies that's not workable, is using open source tooling. For one thing, I think open source is just a great concept. It's nice to give something back and work on something together across different organizations. But also, I think if the source code is free to, like look at and inspect, then first of all, you might be more aware of any kind of vulnerabilities, which will then give you the chance to mitigate that in other places in your system. So I think overall, it will increase trust into the product, because now I can see exactly how it works and what it does and how it does the thing. But also I know where I have to maybe mitigate vulnerabilities. So these are the 4 kind of like objectives that I've decided to kind of go with for the examples that I'm showing you right now. All right. So the setup that I've decided on is like this. So I want, in the end, to have a secret that looks like this, where I have the secret of type opaque, and then I have this data field here, which has an environment key, or a key named environment, that will be dev or prod, and a key named source that will be, in this case, YAML, because I'm reading it from this YAML. And to consume the secret, I'm going to deploy a pod. It's called reading secret. And in the pod, what I'm doing is I'm taking the content of a secret and I'm writing that into the environment of my container. And in the container itself, I'm running this script where I'm just echoing the contents of the secrets. Now, obviously, in production, do not do this at home, ever. This is just for, like, to prove that I'm reading the right secret from the right place. Okay, so when we want to work with secrets with GitOps, we basically have 2 options. One thing we can do is we encrypt the secrets before we put them into the ops repository. And to do that, I'm using a tool called sealed secrets. The other option is that we don't deliver the actual secret at all. What we do is we store the secret somewhere else and we deliver a reference to that secret. So in this example, what I'm doing is I have a HashiCorp Vault that holds the actual content of the secret. And then I'm using the external secrets operator to create references, and this operator will then go to Vault and then pick up the actual secret and put that into my cluster. I forgot to bring myself some water. Wait, there's some. Someone forgot their Coke, or someone left the Coke here, so I'm just gonna drink it right. Sorry about that. Oh, thanks. Okay, so let's look at option number 1. So here we have 3 parts of the architecture. We have a Kubernetes cluster, and we have a GitOps repository. And then we have the machine of the developer. Now this dev machine I put in like dashed lines, because theoretically the Kubernetes cluster and the GitOps repository could be the responsibility of the ops team, and the dev machine would be in the responsibility of the developer. So the whole point here is just that the dev only needs to care about what's happening on their own machine. In this setup, I have the sealed secrets operator. So for those who are not super familiar with the operator pattern, it's basically a controller that lives on your Kubernetes cluster that is constantly monitoring specific resources that you define yourself, so custom resources. And then as soon as the state of one of those resources changes, the controller will do something. That's the basic pattern of operators. So in this case, we have sealed secrets we have a sealed secrets operator, and when we install that onto the cluster, it will create a private and public key pair. And we can use those keys to encrypt and decrypt our secrets. So the first thing that we would do as a developer is we would talk to the operator and ask it to give us a copy of the public key. And this public key we can then use to encrypt our Kubernetes secret. So we start out with an actual Kubernetes secret, and we encrypt it with the help of this public key. And this will be the result of the encryption. So it's a resource called sealed secret. And the interesting part here is this encrypted data field. So here we have the same keys, but the content of so the value is actually encrypted data. So if I look at the secret, I cannot just read the actual content from the secret because I don't have the private key for it. And then I also can pass in some metadata just in case I want to change the name of the secret, or I want to, like have specifically like a specific type. I can put that in here. And once I've sealed my secret, I can then deploy it by putting it into this GitOps repository, and like some mechanism that you're using to deploy, for example, Argo CD or Flux, will then put that secret into the sealed secret into your cluster, where the sealed secrets operator is monitoring the state of all the sealed secrets in the cluster. And once it detects that, it will then take the private key and encrypt that sealed secret and put a Kubernetes secret into your cluster. And this Kubernetes secret is the same, or should be the same, as we started with on the dev machine. So this is the situation on dev. On prod, the idea is that the developer would not obviously seal a secret on the development machine, because we don't want the developer to ever have access to that secret. So in prod, you might want to think about like some automated system, or maybe an operator, like a person from the ops team will seal that secret, so the developer, again, has no access to it. Okay, so quick demo, which I'm not going to do a live demo. There's too many risks. But I created this video for us to look at, and I will do a live commentary, which is almost as good. So what I've done first here is just to show you that this is just a regular Kubernetes cluster. Not quite, but let's just say it is a regular Kubernetes cluster with nothing installed so far. This is our prod cluster. And I'm using a tool called DevSpace that, by pure coincidence, is one of the products that Loft works on. And what it does is it will manage basically the complete life cycle of any environment for me. So it's just like I'm just getting rid of make files. That's pretty much what it does for me right now. So I have this production cluster, and that, as we looked at, so in the production cluster, I already have the sealed secrets controller installed in the default namespace, and then I'm running DevSpace deploy, and it will deploy two things. It will deploy the sealed secret, and it will deploy my pod. So these are the things that I need, and that only I need as as being a developer. I need the secret, and I need whatever consumes the secret. So now when we look into the logs, it will echo out environment prod source YAML. And I can also look at that test secret just to prove that this is not a secret that I've created by myself, but rather this is the secret that the sealed secrets operator created for me. Oh, this is going well. I should have done a live demo. Okay. All right. So for those who are interested in how the background works, okay. So this is what a DevSpace YAML looks like. So all I'm doing, just to show you that I defined a couple of commands to run, and these are the ones that I explained to you before as well. So I have to like fetch the certificate first. By using this tool called kubectl, I can then talk to the sealed secrets controller and ask for that certificate here, and then I will run kubectl to seal my Kubernetes secret, and then I have this sealed secret resource right here that I will deploy, and then the pod that will read the secret and echo the results. So what I'm doing here, and I will just do that really quickly because I think I'm a bit slow on time right now. I'm using vCluster, which will spin up a virtual Kubernetes cluster just to simulate that I'm on two different clusters. Otherwise, if I'm on the same cluster, I can't prove to you that those are different different things that are happening. So here, the only difference is doing the same thing, or deploying the app and the sealed secrets. The only difference is that I'm also deploying the sealed secrets controller, because this is my dev environment, right? So the dev environment is completely empty, and I have to do everything that I did for the deployment here. I'm doing the same thing, except that I'm saying like the env is now dev, and I have to also create the sealed secrets controller. And I'm not going to run this entire demo because, as I said, we're short on time, but I'm sure you will believe me when I tell you that everything worked perfectly because I pre-recorded this. All right. Okay, it's not going to go, won't go into, okay, whatever. All right, so in summary, so when we use sealed secrets, what we need to do is we need to still manage our secrets separately. So the sealed secrets operator will not manage any secrets for you. You still need to do that yourself. You can deliver the secrets now with the rest of the resources in the GitOps repository, and you don't need anything else really. You just need the sealed secret controller with the keys, and whatever consumes your secret, which is really nice and really handy. You can take that public key, that certificate, you can take that and you can share that outside the cluster. So as a developer, you don't need access to the cluster. The operations team can just give the key to you, you can seal your secret, and then just push it onto that repository, and you don't have to, you don't have to ever go to the cluster yourself. The other side of this is that because the public and private keys are created once you are installing the operator, you need to reseal your secret for every environment, because every environment has different key pairs. So this might be something that, I don't know if that's a lot of work or not, but this is something that you need to keep in mind. There's theoretically a way to rotate those keys, so you could even use the same public and private key pairs across multiple environments, but I wouldn't recommend that, because then you're taking the key out of the cluster, and then you've broken the system, like you already kind of weakened the security of that system. So even though it's possible, I wouldn't recommend it. And this was option 1. So now we're looking at option 2, which is using the HashiCorp Vault and external secrets operator. And here we have pretty much the same setup, except that we also have the vault here. And the vault here is in dotted lines, because this can be, in theory, and I've seen that being done a couple of times, the vault can be owned by yet another team, the security team. So we would have an ops team, we would have a dev, and we have a security team. And the vault could live wherever. You can have a shared vault across different environments. In this example that I'm showing you, I've put the vault into the Kubernetes cluster, because it makes a lot of things easier for me, to be honest. But yeah, it doesn't really matter. As long as you can talk to the vault, it doesn't matter where it lives. And here, our secret starts as an entry in the vault, and we will install an external secrets operator in the Kubernetes cluster. It's kind of a similar pattern as the one that we saw with the sealed secrets operator, except with the addition of vault. So here what we have is we have a service account that is associated with the external secrets operator, and that service account is tied to roles and policies inside Vault. So in Vault, you can have policies to define the rights that you have over specific entries, and a role can be linked to one or more policies, and that role is tied to the service account with a service account token. And the thing that ties it together is called a secret store, and we will take a look at what that is and how it looks exactly here. So the secret store is another custom resource definition. It has a name. It has this information here, which tells us where the vault lives. So from the cluster secrets, from the secret store here, we just access vault.vault, and that is a service that lives on the cluster, because the vault lives on the cluster. So we say, go to the server behind the path KV, because it's a key value store. You can find everything that you need to authenticate. And this is kind of we can define which specific authentication type we want to use. This is a specific Kubernetes one. And we have the service account token mounted here behind Kubernetes, and we tell it to assume the ISO role that I also have to create. So with that setup, what we can do now is we can create an external secret on our local machine. And the external secret is a reference to this entry here in the vault. So the way that it looks is pretty straightforward, actually. We have a field here called the secret store ref, and that just references that secret store, which in our case is the Vault backend. And the nice thing here that it's completely pluggable. So if we ever decide that we want to move away from Vault and instead store our secrets in, like, I don't know, Google Secrets Manager or whatever, then we just have to switch out the reference here. We have to create that new secret store, and we can switch out the reference here, and everything else will work exactly the same. So that's really convenient. And then here we define the target secret. So we want to create a secret that's called test secret. And we basically say, okay, there is a key in Vault that's called test secret, and that key has a property called env. Can you please take the value and map that to this secret key env? And the same with source. So we end up with the same type of secret again, as I showed you before. So once we create that external secret, we can now deliver it in the same way to the GitOps repository, and the whatever mechanism does your deployment will pick that up, install the external, deploy the external secrets onto the cluster. The operator will constantly monitor for changes. Once it picks up a change, it will then go to the service account. The service account will talk to the secret store to get the path where it can authenticate itself with, assume that role, pick up the entry from Vault, and then bring it all the way back to the operator, where it will then create a Kubernetes secret. Okay, I have to drink something. Sorry, I'm a bit low energy today. All right, so again, just let's take a quick look at this demo, where it's the same situation as before. I have created this cluster, which is like a production cluster, and everything's already installed, like Vault and the external secrets operator are all there. So when I start my local environment stuff, what I need to do is I need to create that secret, which I already did. This is why I get a 400, because I already created it before. And I will have to deploy the external secret, so that's the reference, and my application. And I had to open a separate shell because there's a port forward running for Vault. And, yeah, okay, so already looked at the logs here, where it says env dev, and now the source is Vault. Oh, this is actually not right, because the env should be prod, so that wasn't great. Why? Hotkeys do not work in on slides, apparently. So yeah, so let's take a quick look at the dev space YAML, just so we can look at what actually happens. So what we're doing here is we have to start the Vault. So start dev is just like something that runs in the dev mode. In this case, this is just to create a port forward for Vault itself, so we can talk to it directly. And once we've done that, we have to create the Vault entry, which is just 2 Vault commands. So, and this is also the mistake that I made, is right here, because I hard-coded, I don't know if you can see that, I hard-coded test secret env equals dev instead of passing in the environment name. That's on me. And yeah, I have to deploy the external secret and the pod for the that consumes that secret. And that, again, the pod is exactly the same across all the examples here, because that's kind of the heart of it, is that I don't have to change the pod, and I don't have to change any configuration for the pod. It's purely in the secret that I'm deploying. And okay, so this one is now the development environment, which I think we can skip, because this is pretty much the same, except that I'm just installing Vault and the external secrets operator. All right, so, okay, I'm almost done. So in summary, the Vault and external secrets operator are a bit more involved, which might be good, because if you are, you know, like 100 people, you don't want to seal every single secret by yourself, probably. So the good thing here is that the external secrets operator works with many cloud providers, so you don't have to use Vault. If you want to use any of the vendor offerings around secret management, you can do that as well. And now dev teams, they can safely manage secrets through Vault without ever having to see the content. Also, the best practices around security are there. So as I said before, with the sealed secrets example, is that you don't actually have secret management, but with Vault you do. So this is a big plus, of course. Yeah, as I said, the setup is a bit more elaborate, but again, if you're scaling up, then this might be a good alternative. If you're just 2 people, you might not want to do all of this yourself. You probably will be fine with sealing secrets yourself. Okay, so I'm almost done. As I said, if you want to take a look at the demo, you can check out this GitHub repository. You can scan the QR code. I promise there's no Rick Astley behind it. This QR code just leads to the repository, and then you can just look for yourself. So yeah, a couple of things, couple of feedback that I got after I've given this talk a couple of times, which is great. If you have any feedback for me, that would be lovely. So what we need to keep in mind is that all I looked at was at the supply chain. So this is just securing the secrets in motion, not in rest. So on your cluster, the secrets are still unencrypted, because all we did was we're still ending up with Kubernetes secrets, and everyone who has access to your cluster still has access to the secrets. So we didn't solve any of those problems. You can, instead of using Kubernetes secrets, obviously you can do things like reading entries from the vault in your application itself, but then that's kind of like not the GitOps way to do things. So that's why I didn't show that. But yeah, generally, we are still ending up with readable Kubernetes secrets in the end, which also means that you need to still secure your cluster, right? Like all these things still need to be done. We just talked about delivering secrets. All right, so final 2 thoughts that I want to leave you all with. This is a cartoon, probably a manager standing there saying, like, first, I've decided we need a SQL database. Second, I need you to tell me what a SQL database is. So this is kind of Kubernetes. So with the exception of pods, Kubernetes doesn't really understand its resources. Kubernetes doesn't manage secrets. Kubernetes manages a resource, the lifecycle of a resource that is called secrets, but it doesn't really understand what it does and why. So you need to manage secrets yourself in some way. And finally, to get back to the image of desire paths, once you kind of like want to create this process and this way to deal with secrets, you need to understand how developers are working, how the developers in your organization are working with secrets, and yeah, how they want to work in the future with secrets, and like what their problems is and what problems they want to have solved, instead of you trying to enforce your vision of how it needs to be done, you as a platform engineer. And yeah, that was it. If you have any questions, I might have time to answer them. Thank you.
I think we're right about time. So,
Sorry?
I think we're right at about time.
Okay, so if you have questions, you can ask me later down there.